Okay, so first of all, the example of eval, which I gave a very trivial example. Now I have found a very interesting one, a small one, but still very interesting. So uh, let us look at the function definition, where I have three parameters, A, B, and condition. Okay. Now A and B, let us assume that they are integer. I mean, this is a very simple one. Integer variable, and the condition is unknown at this point. Okay, so this is where the eval will shine. So what you do is, instead of saying A greater than B or A equals to B or A less than B, etc., etc., inside the function body, you can simply eval the condition itself. And within this condition, when you will call the function, you will pass the comparison operator, or not operator, the expression for comparison. Okay, so what you do essentially, I mean, this is again a trivial example. If the eval condition is true, then return A plus B, and if it is not otherwise, you return A minus B. So this is a very simple function. Now, what you can do is you can simply say, now function, you call the function, you pass 2 and 3 as A and B, and within double quote, that means as a string, you pass A greater than B. Okay, so in this function, now the condition is a string which is A greater than B, and then you eval that string. So Python now checks that indeed there are two variables A and B in this namespace, in this scope. So it will find A and B, and it will compare the two values A and B. If it is true, then it will return the first expression. Otherwise, it will return the second expression. So this is something which actually we use in many places. Okay, I'll show you another place which is a very important one, where underneath you actually do an eval. So I hope now this answers the question, that it is for your flexibility, not for speeding up, because here actually you might lose some speed because you are evaluating a string in runtime. Okay, so in fact you will lose some performance, but here losing the performance is not a big problem, because you are gaining a lot in flexibility and gaining a lot in dynamicity. Okay, so we might use it. So now the example is, I'll share the notebook, so you will be able to do, able to check. Also, you see that Python, instead of checking A equals to B, you can also even say A is B, which is also true. A is not B, stuff like that you can do. Okay. Now, coming back to the other question about why 1.5 and plus 3.14 gave me a value which is after the decimal point, there is a 1 sitting after 10, 15 zeros. So this, I think what I answered is partially correct. That is the representation. Okay, so we are representing a decimal number here, a floating number, in terms of binary. Now, if you seriously think about it, a binary number can never exactly represent that decimal number. Okay, to whatever extent you go with zeros and one. So if you now take two values, add them, then you have to truncate the precision of both the values at the same position. I mean, whatever is that absolute position doesn't matter. You have to really go up to some number of bits, and you stop, and then you add them up. So both the representation, both the binary representation of the decimal are approximate. Okay. So if you add them up, then you will get another binary representation. And when you convert it into a decimal, so you never get the exact value. That is why it depends on, I mean, that one which we got may even come after some more zeros. It depends on the implementation of Python, but it is never exact. That is why we, for example, this one now, this line is true. In the morning, something I could not do. You see that 0.1 plus 0.1 plus 0.1. if you assume that they are exact, then they should be equals to 3.3. But if you execute this expression on the on the Jupyter notebook or on the command wherever, you see that this is false. Exactly. So, and these mostly, I mean, this will work. This will be almost always true for fractional numbers, not for integral numbers, of course, because integral numbers you will be able to represent exactly. Okay. So I think this answers the question. If you want to know more, and certainly you should want to know more, that there is already not this one. This is about the eval function, which we saw, and they are also in the Python documentation. I thought I put it somewhere. Okay, I'll edit it. Also, there are some documentation about it, which I will add. And the third one is that I realized that Python 3 now, in order to represent a long number, you don't need the capital L anymore in Python 3. But you just have to specify the number as a big number. When it will cross the integer, it will be automatically a long integer. Okay? So you don't have to really specify the L. I mean, Python will take care of in all cases whenever it is needed to make a long integer. Okay. So I hope this answers the three questions. So I also want to add one more thing which we discussed, which is called declarative programming. I said imperative programming is easy. Whatever we do here are mostly imperative programming, but of course this eval part is like declarative programming. As you can easily guess, that you are not really you are actually taking a string. Within the string you are giving your algorithm, and you are asking Python to understand that it's a valid thing. And at that point you also make sure that you have both A and B, okay, available as two variables inside the function. Okay? So another real example is when you will actually do your analysis with the root data frame. Okay, I just want to show the example but not go into any detail. So here is one example of a root data frame with which you can do you can analyze actually CMS open data. Okay, so there are a lot of things. You have to use root from Python, and then you create the data frame from the root file. And this is not something that is what I am referring to. So the next two lines, the what you do now is that you filter out once you have the root file, and in the root file you have many events, and each event got some property, and you want to check whether a certain event, any event actually, has got two muons. Now in the root file, that variable which tells you whether there are two muons is called n muon. The number of the name of the variable is n muon, and you see that from one data frame actually you are filtering out all the events which do not have two muons, and you are creating another data frame. And you see that here you are not doing any imperative programming, you are simply passing a string. Okay, so which is okay. Now somebody else will create imperative code from your declarative code. So this is your declarative or symbolic statement. From the symbolic statement, there are other layers before the Python interpreter really comes, that will create the imperative code. That means somewhere there will be an if statement, and in this if statement this expression will be evaled. Okay, this expression will be eval. So this is also one example, and at that point the n muon must be present. Otherwise it will tell you that the n muon variable is not understood. Okay, so this is one of the examples of declarative programming. Similarly, for the second one, you see that now I am checking the charge of the two muons, and here it looks very misleading, because suddenly you are saying that muon charge 0 and muon charge 1 should not be the same. Okay, so you can, as you can see, you can not only use single variable, scalar variable, you can also use array variables here in a declarative way. Okay, so declarative programming is very powerful, because it takes away all the gory details of your programming and gives you a much simpler interface. And as I told you in the morning that the machine learning algorithms are mostly declarative, because they are also, there's a lot of things going at the back end behind the hood, but it gives you a much simpler interface to work. Okay. On the other hand, as you can easily see that if somebody doesn't tell you that this is Python code, you will never be able to tell me that this is Python code. This could be Python code, this could be C++, this could be anything. Okay, so declarative programming has the advantage and the disadvantage that it takes away the main features of a programming language, and all the programming languages start to look the same. Okay, so some of them are more efficient, some of them may not be. For example, here, although I say it, Python is much slower than C++, when you will use root data frame with Python and with C++, you will see that Python is not that slow, because here you don't do anything Python. Okay, so you just do declarative programming, and then that declarative programming part can be directly translated into C++. You don't have to go through a lot of Python. Okay, so because you go directly to C++, bypassing a lot of Python steps, and then you just call root, then Python is very, very efficient also compared to the C++ version of the data frame. Okay, so I will share that this notebook. Now, we'll go straight to this, not this one. We'll go straight to list now, data type. I told you that there are 6 data types, built-in data types in Python with which we can work. Okay, so the most important ones are the list, then the dictionary, the tuple, the file, the string, and of course the numbers. Okay, so the numbers, I think we have discussed a little bit. Now we will talk about the list, okay, and the others. Okay, now let us start with the list. We have also seen how to create one of the simplest list, which is with the range function. So there is an inbuilt function range, like for example range 0 or range 10, then it will create a list 0 to 9. Okay, with Python 2, this line was good enough. It will actually create a list and store the list in the variable on the left hand side called L. But with Python 3, you have to be more explicit. So for example, if I execute it, I have already done it some time back, and if I look at the type of the variable, I see that it's not a list variable, but it is called a range object. Okay, so if I put a list on top of this and execute it, and then I execute this one, and I see that now I have a list. Okay, so if I print it, so let us insert another below and just put L here, and I see that I have 0 to 9. Okay, so now I want to show you some list manipulation, not manipulation, how to create another list from this list. Okay, so I will not really follow whatever is there in my slides. I'll just try to have a very simple introduction first. So let us say I want to create another list from this list where each variable is multiplied by itself. So 0, 1, 4, 9, etc., etc. How do we do that? Okay, so there are 3 ways in Python with which, at least 3 ways with which you can do that. So let us try to do the simplest one. The simplest one is the following. I create an empty list. Now you know how to create an empty list. The empty list can be created with L. If the name of the variable is L1, L1 equals to just the empty boxes. You could also do list. They are the same. Okay, so I will not do that. I'll simply do this. So this is an empty list. Then I loop over the original list, and we saw the for loop for I in L. And remember that this for loop is an iterator. iterator based loop. That means each time I iterate over the sequence, so lists are generally called sequence, I will get the next number. So I will start with 0, and every time I iterate it will get 1, 2, 3, etc. up to 9. And what you do is you multiply I with I and append that value to the empty list. So the empty list slowly grows. So I can execute that, and if I enter it, and I see that indeed I have 0 to 81. So this is the first method. It works, and why not? Okay, so it is the same in any language, and you will do it. Now there are two more ways. Okay, if this looks ugly to you, then or if you think that there I want to use something else, you will do that. So there are two more ways. One way is this. In Python, there are functional programming. Functional programming is something where you will use a function, okay, and you have a tool which will apply the function on each value of that sequence, okay, and automatically that function will get its argument. So the function will that tool here, the tool is called map. I'll just show you the example. The map is a tool which will take each individual element from a list here, and it will pass to a function automatically, and inside the function whatever you have to do you will do, and the function will return, and the map will automatically append that value to a new list. So let us say L2 equals to empty list. Okay, so then what you do is the following. You say, actually you don't have to even create the empty list because it will be automatically done. So you say map is a tool here. The map is the utility. Okay, so before I do the map, I also do something else. I create a little function. So now we know how to create a little function, square x to return x into x. Okay, so this I think you have it is clear. So you have a function with the definitions def, you name it square, and you put x, which is the argument, and it will return x into x. So for example, I could execute it. I insert another cell below. I insert another cell below, and I say square 4, which will return me 16. So this works. Okay. So now I will use this square function because it's called functional programming inside the map utility. So I will simply say square, and as a second argument, I will pass my list called L. L is my original list. L is my original list. So I am passing my to the map utility the function which I want to apply on each element of the list. Okay, so this will be automatically done instead of two lines here, okay, here you have only one line, and it should work in this condition. It should work. Let us see. And you see that the L2 has worked, and if I type L2, you see that it, I always forget, so I have to put also a list, unfortunately, to make things messier. Okay, in Python 3. In Python 2, the earlier line would work. Now it will not work, but here the L2 works, and L2 gives you the same result as L1, where you did it in 2 lines. Here you are doing it in 1 line. Of course, well, it is up because you have also created the function, so it is not really that that reduction in number of lines. So the third one, so this is the second one. Now the third one, we have four ways of doing it, and I just want to show demonstrate that with a very simple example, but there will be more complex examples which you will eventually learn about. So instead of creating a function for such a trivial thing, you can also use the function on the fly, okay, with an unnamed function, and the unnamed function is called a lambda. Okay, in Python, the unnamed function is called a lambda. How do you do that? You can say, let's say g equals to lambda x, something like this. So you see that there is no, on the right hand side, there is no name. You are not using def, etc., etc. You are simply saying lambda, which is a generic name for a function which you want to, unnamed function. Lambda, it will take an argument x and it will return x into x. Okay, so it should work. Let us see. So it works. If I insert another here, I can also see L3 equals to map. Then I say G and I say L. And also I have to put list. Okay. No. Maybe I have to put return here. Otherwise it will not work. No. G. Why is it not working? No, it may work. So I have to print it. I have to print it. So it works. L3 also works. So this one is not correct. This was correct. So this was correct. So this is with lambda. Okay, this is lambda. Now you will think, why do you have to define a lambda? In fact, you don't have to define a lambda. What you can simply do is the following. You can simply say L4 equals to list of map of lambda x into something and then L. So you are not defining a lambda, but you are using the lambda on the fly. Okay. Now, once again, if this lambda function is very complex, you will not do it on the fly. You will either define a true function with the function name, or at least with the lambda, and use the function pointer or function reference here. But for simple things like what we have done here, just a square, you don't have to really do anything else. You just put the lambda in place. Okay. And you may ask why I have to do it, because here you are not really using any extra memory. If you create a function or if you create a lambda function, okay, in both cases you are creating some, you are using some memory which will be taken away after some time. But here in this case, everything is within the scope. When the function goes away, then it is it will just remove all the used memory at that point itself. Okay, so this is, that way you are much cleaner and you also have better performance. So you can we can do that. No, something is wrong. The lambda, the spelling is wrong. Lambda. Okay, and then you can print. Oops. So I delete. Let us see L4. So L4 also works. So we have seen many ways of playing with the list. Okay, in particular when you convert one list into another. But in this case, in all these cases, what you are doing is that you are you are doing a one-to-one correspondence, that for each element of the input, you are creating an output element. So the last one is very important, and sometimes it's quite complex. But for this example, okay, it's not that difficult. It's called the list comprehension. List comprehension is where, again, in a single line, you will be able to create or I mean, not create, manipulate one list into another list. Okay. So for example, now I have L5. L5 is, you just put this, because this is as if you are creating an empty list, but it's not an empty list. What you do is the for I in L. This also we know. Okay. But now instead of putting it on the left hand side, I am putting it on the right hand side. And what I'm doing, that is why it is little bit confusing for those who have not already learned it. So this is a very simple example of a list comprehension. That means you are creating a list from some expression. Okay. And that expression, the expression part is on the left hand side, that will be output, and the other part on the right hand side is the input, or not input, is the iteration over the input. So this is L5. Let us see whether this works. This should also work. And if I insert a cell above and I say L5, and you see that once again that you get the same thing. Okay. So any question up to this point? Was it too fast? Okay, I hope you are still listening to me. So this is a list, and from that, if I give you a single list, you can do a lot of things. You can append more stuff, you can remove stuff from there, and so on. But that was one thing. But we are more concerned about the functional programming techniques, and here I have already shown you one of the functional programming techniques with map, and also lambda. So in Python there are like functions are first class objects. I will also touch upon the functions, which we have already defined a few times here and there. Okay. And the functional programming is based on 4 elements. One is called lambda, which we have discussed for a simple thing, and even if you have a more complex stuff, it is still fine. Then you have 3 functional tools. One is called map, the other 2 are called filter and reduce, which we'll come to, and of course the last one is the list comprehension. Okay. And you have seen that list comprehension right now has the cleanest syntax. Map was pretty clean, but it might also become very complex. Okay. List comprehension may also become confusing if you have more than one such dimension. Okay. But for a single dimension where we have only one loop, I think it's pretty easy, and you will be mostly using the list comprehension, because it was also found that list comprehension is slightly more performant than map or the other one. Okay. No, the first one, very simple one, is actually prohibited in Python. You know that for long arrays, long lists, using the for loop is not the right way to do. You should, so because there you are really doing an imperative programming where you are looping by manually over everything, while in the case of map you are not doing the looping yourself. That means some optimization is already done inside the map, which will be used. And list comprehension is also optimized because it has a particular syntax which you cannot really change, and it can be optimized. So the list comprehension, because of the clean syntax, is the preferred one. Okay. So now for example, let us look at the filter. Okay. So let me go to the slides also, just for no, before I do that, I have a couple of quiz, or 3 quizzes, which I want to also discuss with you. I hope you will participate. Let us see. Not this one, this one. Now I have a list. Okay. I have a list which is red apple, green apple, banana, and kiwi. Okay. If there are anybody who also participated last time, you may recall that it was there as a quiz. So what I'm going to do is I'm going to loop over the fruits, because fruits is my list. I'm looping over the fruit, and in each iteration I get the fruit value. So first I will get red apple, green apple, banana, and kiwi. Then I'm checking with the if statement, and here you can see that a lot of Python syntaxes are inbuilt. Here, if apple in fruit, that means, for example, this one and this one, they have apple in it. Okay, they name apple in it, so they will be, so this line will be true for this one and this one. Okay, if apple in fruit, then fruits the list, you append that fruit somehow. So what will happen if I run this program? Can somebody tell me?
I think we should not get any output because like a red apple is it is considered as a whole an object.
No, I mean, as I said, this one I can show you. Let me before I do that, I have, let's say, s equals to, okay, this I can, red apple. Okay, so I give it a name. I give it a name, and then I check whether this line is true, should be true or false. So I say apple in s. If I just type this in Python, it will tell me true. Okay, so this means this line, as I say, this line will be true for this element and this element. That means for when fruit is red apple, this line will be true. When fruit is green apple, this line will also be true. That means you are going inside.
Okay.
You are convinced that for these two cases it will be true. I have shown you.
Yes, sir.
So then what will be the answer? Anybody?
The answer will be red apple and green apple.
Anybody else?
We
If you
will get
want, I
another two copies of red apple and green apple. Like we will have two copies of red apple and green apple, and we will
if
see printed that we added a red apple and green apple.
yes, but anything more?
I
You are
think
correct,
it's
almost correct, but you have to be a little bit more
Okay, so red
aggressive
apple and green apple will be added at the last positions.
in the
so the loop will
fruits.
be
In,
infinite.
yes, exactly. Who said? Somebody said correctly. So I mean, first you said that there will be two more copies, but these two more copies will be added in that place in fruits. Okay, that means fruits, the list has already grown. So when it loops again, so you have red apple, green apple, banana, kiwi, red apple, green apple, 6 elements in the first pass. But when you again touch the second red apple, again it will add another green apple, and so on. So it will, if I don't want to actually execute it, it will be an infinite loop. Everybody is convinced? Or should I execute? Then we'll try to kill the kernel. You see? Okay, so I have to kill the kernel. Hopefully. Okay. And maybe I clean the. Fine with everybody, I hope. Okay, so the second one, where is that? Okay, this one. So I have a function which is called square. This is much simpler. Square, where I am passing a items, which is a sequence. So let's call it a sequence. Sequence is my list. So what it does, it loops over the sequence and it reassigns the sequence by taking the individual elements of the original sequence and multiplying with the same value. So it is essentially squaring each element. Okay? So here you first of all you learn a very important thing. You learn a very important idiomatic thing, that in Python there is an inbuilt function called enumerate. Okay, if you apply enumerate on a sequence, it will give you two things. It will give you the index of a variable and the variable value. So if you have a if you have 10 1 2 3 4 5, if I do enumerate, then it will be 0 1. So enumerate will return here 0 1, then it will return 1 2, which is 1 is the index, 2 is the value, then 2 the value is 3, and then 3 value is 4, etc., etc. So this you should always use. This is the idiomatic way. The other option is that to start I equals to 0, then for something I equals to I plus 1, etc., etc. You don't have to do that. In Python, enumerate will give you both the values as a tuple. So this one we saw in the morning, that a tuple is just one value comma another value. So that is a tuple data type. Okay, so this one, now you can see that if I do enumerate on the sequence, so the first of all, the I will be the first index of the sequence, and X will be the first value of the sequence. So that is what I'm doing. I'm taking the first index, which I am using again on the sequence itself. So sequence of 0, and I'm taking the first value X, then X into X. So if I run over everything, then the whole sequence is now rewritten. Okay, whole sequence is now ready. Have you seen the point? Can somebody?
Yes, sir.
Okay, so now this is in stark contrast with let's say C. In C or C++, by default, if some of you know, that when you pass a sequence or whatever by value to a function, that value is always a read-only value or variable. That means whatever change you do inside the function is not reflected back outside the function. That is in C and C++, because C and C++ passes value by value. But whatever it passes, passes the object by value. It will keep a copy of the original object, and it will keep make a copy of the original object, keep the original object intact, and pass only the copy. Now whatever you do inside the function, when the function returns, because that copy is a local copy, okay, that copy is a local copy, it will go away. In Python, we said that if I have a variable, although the sequence here in Python also, sequence should have been a local one, but because it is passed by reference, and although the function came back, before the function came back, that sequence was totally altered, so that will be reflected here. So this is a big difference, but if you don't know C++, it's fine, because this is the, nowadays, this is the natural one. C and C++ are supposed to be unnatural one. And that is why you will see that in C++, we had to introduce references, we had to introduce pointers, etc., in order to avoid this. Okay. While in Python, you don't have any, you have only a very uniform data type. In Java, you have a very uniform data type, and that because everything is passed by reference. Okay, so if I now execute the two, this one and this one, you will see that the print of A will first print the original array, and after you call square of A, and if you print A again, you see that it has been already altered. So this you have to keep in mind. If you assume that you are doing something, and I mean, this one looks very trivial, but there could be, your function could be much more complex than this, and by inadvertently you may change the sequence which you really didn't want to do, and then the sequence is changed. Then that you have to take care that, because you are passing the original variable by reference, there is no way that you can stop it from being mistakenly overwritten. Okay, so this is something you have to understand. Okay, so the third one, The third one is not fully we have not read it, but I said I'm not really following all the sequences. So now I'll talk about another interesting thing, which is file, because I said list, dictionary. I'll come to file. Files are very important, in particular input file which you read. Okay, and Python gives you very high level way of reading files. So one of them is the following. So you have, if you want to open a file, a text file, for example, okay, you say, let us say I have a file called run3.txt. So you simply say open, within bracket you pass the name of the file as a string, and Python will open the file and return a file handle as if, okay, as if you have called a function and a function has returned a file handle. Now what you can do, you can read the whole file in a single go. Here I'm talking about a very small file, so reading the whole file in a single go isn't a big problem. But if you have a huge file with millions of entries, then you have to be careful, because it will consume a lot of memory, the reading the file. So here I'm simply reading the whole file. And reading the whole file means there is a method of the, and this is an object, by the way, which I have not discussed, but I probably will never discuss much about object orientation, and we will, and because Python is fully object oriented, we will continue using it. So if f is the object, it has a method called read lines, and read lines will read the whole file line after line and convert into a list. Okay, so here I can show you, it's already shown here. You see that read lines, if I print the read line, it is showing you that it's a list. It's a list. And moreover, what it is showing is all the values of this file. So there are only few lines in the file, and because there is a new line, in the file after each line, so it is also showing the new line. Okay, so what is missing here? So let's say now I want to read this. Now I want to read the whole thing. I will remove the new lines. I will remove the new lines. I will convert each of the numbers. You can see, I can show you also here that each line is actually only one number. The first line is 1.578, then 73, 3.14, etc. So what I'm going to do is that I will first strip the new line characters, then I will convert them. I'll convert them from string. You can see that they are string, from string to floating point number, and I convert them into another list with only floating point number. That is my purpose here. Okay, and after I have done that, I see that there is nothing. It's an empty list. Although I will show you, without changing any code, I will show you that I have done it correctly. So you have to tell me in these two examples what is wrong. If you, I mean, I'm assuming that you have some experience with some programming language. So you should, or even if it's not there, even from common sense, maybe you will be able to guess what has gone wrong, so that even if I assure you that this line is correct, in principle, I should have an output of the same list without the new line and without the code. But I don't have. I have only an empty list. Anybody? Any guess? Okay. So if you don't have that guess, because you have probably, so let us put it this way. Instead of printing, I am taking them in a list. This also I can do. Okay, this also I can do. Instead of printing, then I take this, so nothing is printed. And if you want to print it really, you just say L, and you see that it prints. Okay, everything is printed correctly as the, and if I put here L, if I put L here, because L is the original array, and then I what is wrong? Okay, wait, maybe something is missing. Float strip, not this one here, maybe. Float of this X strip 1 2 3 4 1 2 3 4. Okay, now you can see that we get the result. Do you see that? So can you tell me, if I go back to the original one, what could be the problem? Okay, so if you still cannot, so the point is that when you call read lines, Python more or less tries to follow the C philosophy of reading a file by shifting the pointer, of the reading. So when you say read lines, what Python will do is that Python will go up to the end of the file. Okay, so the first read lines will take Python to the end of the file. So, and then you remember that I again call read lines here, but Python could not, unless I unwin the whole thing and go to the beginning of the file again, Python would not be able to find anything to read. And that is why in the very first time it was giving me an empty list. And now that I am calling read lines and saving the output of the read lines in a list, and I am passing to the map, lambda, etc., the list itself, this is no longer the case, and Python can actually do whatever is it needs to do. Now, coming to this line, I think now it is not very unfamiliar to you. So what you do is that you have list. This is Python 3 stuff. Map, map will take two arguments. One is a lambda from here to here, and the other one is the original list. The original list is L, which is fine. And because lambda takes only one argument, which is X, and after the colon, it is the body of the function. It is the body of the function. What it does, it takes the X, which is a string. Okay, even if it's a character, it's a string, and you do R strip. No, it's not a character, it's a set of characters, it's a string. You do R strip. That means R strip means you strip the last character from the right. You strip the last character from the right. So if you take one such string and strip the last character from right, then you are essentially removing the new line character, which is a single character. Okay, so if you do a single character, then this one from X dot R strip actually becomes 1.578, but it is still a string. So you do a float on top of that, and it becomes float. Okay, and that float you actually append to the output list. So I think although this looks very complex, it is not very difficult. The alternative would be b equals to let us say for x in L, for x in L, x dot r strip and a float on top of that. So let us see whether this works. I commented this out. I make it A, and L is my input list. So I take X, that means each value as a string with the new line. Then I do R strip, so the new line goes away. I still have the string, and then I do a float of that. And so let us say, and you see that it still works. And although this one looks a little daunting for you, this one should be much cleaner. So this is another example why whenever possible you will use the list comprehension in favor of anything else. I mean, not in favor. So you will, I mean, you don't you map and map, I think these days very few people use because of uh, the advent of list comprehension. But before list comprehension was introduced in late to version Python 2, then the map and filter etc were used quite seriously. Even today it is used. That is why we still call it functional programming. Okay, so but this is not the end of this example, because this example has a little bit more. We have discussed about the problem that if you so in a single example we have seen how a very simple way of opening a file, which is not the canonical way, by the way, because this file may not exist. If the file doesn't exist, you should not take this action. Okay, this file may be open and read lines may read some garbage. In that case also you should take care of that. So this one is not a canonical way. We need you will find example, you will need to do more. Okay, so fine. This line, as I said, you can use both of them without any problem. I will use the list comprehension. Now, once you have A, the next part of the code says that you take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You take the first five, you sort it. Okay, let us say in ascending order or descending order, whatever, you sort it, and the rest of the thing you just reverse it. So you have a single list and you take the first 5 elements, just put them in a sorted order, and rest of the stuff you just put in a reverse order. Okay, so you can do that. So if you do that, how do you do that? In Python there are called sorted and reversed. So what you do is you take A, and from the beginning to 5 is empty colon 5. This is the way you specify a range for a list. Okay, so this means from 0 to 4, 1 2 3 4 0 to 4, and from 5 onwards means 5 and open, you just do the reversed. So there are inbuilt functions called sorted and reversed, and you do that sort and you put it back in the original array. You do that reversed and put it back in the original array. Okay, so I can execute that and then you will see what happens. Okay, so you can see that for the first five elements I have done something. One, so it is ascending order, 1, 1.5, 3 up to 7.3, and for the rest of the stuff I have just reversed it. Okay, so this is one of the non-trivial examples when it comes to your work, that you may have to munge your data. So you read from a file, you read all the data from a file, and maybe you have to cut out some column, you have to reverse take some column from one place, put it as another column, and so on, before you can actually use it as input to a particular algorithm. Okay, so in Python it's not very difficult to do that. You have to really understand the read file, and then you read the file, you change the column, etc., etc. So there I will give you some exercise. I will share some exercises with you where you will really need to do some exercise, some of this. Okay, so this is something I wanted to discuss. Okay, so let's see what else I have today. This we have done. I'm not going to talk about all the facilities of a list. Okay, so for example, I will just show you. So this is data type. This was done today in the morning. So the second, so okay, now let us go very quickly through the Python basics. So control flow, you have the if statement, and Python statement. If it ends with a colon, that means it is creating a new scope. Okay, it creates a new scope. Then in Python white space is necessary, is important, so there must be some indentation. So Python code without the indentation actually doesn't work. So for example, here you are saying x, then what you do, you take from the terminal one input, you say enter an integer, you will enter an integer, it will be converted into an integer and assigned to x. So now you say if x is less than 0, do something. If it is x equals to 0, then print something. If it is equals to 1, blah blah blah. And you see that unlike C++, you have not else if, but you have elif. Okay, so if, elif, you can continue with the elif, and finally you have the else. Okay, so this is a different thing, and in each case you create a new scope by putting a semicolon. Okay, so this is already written. So this is first thing. Then you have the important in Python, because Python is very strict about its own grammar. Like in C++, you can say one if statement, and if statement may not have any body. Okay, you may have a while statement which may not have any body. You just put while true, and compiler will accept. But in Python it doesn't. For example, if you want to do an infinite loop, in Python, you can simply say while true. Okay, so that while true means true is one, it's always true unless I put something. But Python will not allow you to do that. It will require a body. So either you print something which is not really the right thing to do, because then it will continue to print, but you have to give something. What do you give? So there is a statement called pass. So you can just put a pass. So then Python is happy. It will just sit there in an infinite loop. Okay, okay, so this is the second one. So this is syntactically required, otherwise you will not be able to even execute it.
Sir,
For
can you
loop,
hear me?
yes.
So for the pass statement,
Yeah,
how is it different from like how we use the continue statement? Let's say in this while case.
in this case you can, yeah, you can also do continue, but I mean here continue comes with some logic. No, because you say continue or break if some condition is met, or if it fails. You can do it, you can do it. But for example, here let us take the other example. So let us say I have an integer. If I is greater than 0, I don't want to do anything right now. Okay,
Mhm.
but else I will take some action. So in that case also you are in trouble, because if now you cannot put continue, you cannot put anything, because it's an if statement. But you have to put something, otherwise Python will not allow you to compile, I mean parse the logic. So you have to put a pass here, hoping that in future when you have some logic for I greater than 0, I'll put it. For the time being, as a placeholder, I put pass here. You can certainly, as you said, here you can put continue. Okay, here you can
Mhm.
put continue, it will go to the other one. But usually continue is not the right one, because we do continue if certain condition is met, or break when certain conditions fail. Okay, so that way
Right.
they introduce the pass. Okay,
Just one more thing. So if I were to give any other statement just after pass, would that be executed?
no, no, pass
Okay.
after that it will not. Yes, after that you have already said. If I loops we have already seen, which is the for loop, and also we have the while loop will be very similar to other languages. You know that. Then in Python, when you want to come out of the innermost loop, or you want to continue to the next element of the innermost loop, you have break and continue respectively. So the continue is that, for example, if you loop over 10, range 10 0 to 9, and if you only want to print where this condition fails, then you say if I, then the residual equals to 0, then continue the even or odd, and in other case you will just print it. Similarly, you can say that I have I 0 to 9. If the value, if the square of the value is greater than 25, I want to come out of the loop. So then you use break. So this is the same as C and C++. Continue and break statement applies. Okay, but these are simple stuff. Okay, these I have already shown. One very important point of Python is that Python has a very uniform way of iterating over all the sequences. So Python assumes that list is a sequence, tuple is a sequence, dictionary, which we have not looked at, is a sequence, then a string, which we have seen a few times, is a character, a list of characters is also a list. So we'll be able to iterate them in the right way. Even a file is a list of lines. A line is a list of characters, or first list of strings, and then a string is a list of character. A file can also be traversed in the same way. So if you look at all the five uh, the data types and you try to do iteration, you see that you can iterate them exactly the same way. Okay, there is no difference from one to the other, and that is something which makes Python very acceptable and very I mean it's a very friendly to the developer friendly. Okay, and this you can, for example, this one, you just open a file, you simply say that I open a file, I don't even say read line, etc., and Python will do the rest for you, whatever is needed. You just open the file and you iterate, and Python will as if call the read lines and create a list and allow you to iterate over them. Similarly, when you say that for car in within quote 1 to 3, from this within quote 1 to 3, it will create a string. From the string, it will create a list at that point dynamically and allow you to iterate over. Okay, and of course the other three are more by definition they have. Here, for example, here again there are some magic, because this is a dictionary. I told you that dictionary means there will be a key value pair separated by one colon, and each pair will be separated by comma, and they will be within a pair of parentheses. So now this is the key and this is the key, and these two are the value. When you loop over them, actually you are looping over the key by default. Okay, you are looping. You can also do more, which we will come to, but you are looping over the key. So here it will print only the key. But anyhow, the way you iterate over them is exactly the same. This is something very important. Okay, so I think I have to now show you some example about the filter, and so I will skip some part which will come to tomorrow. So before that, I want to show you something again. As I said, these are the basics which one should know. That in Python, everything is an object, we said. Okay, so let us show that even an integer is an object. And we know that object has some properties. Each object has some properties, and it has got some behavior also. That means it can take some action as well. So now let us see one novel thing. Okay, so which tells you that if I ask you to swap two values in Python, okay, two variables, not two values, two variables in Python, and the variables are a and b. Okay, so what you will do is something like this: a comma b equals to b comma a. This is just for you to know that it's as simple as that. Okay, in Python you can just swap the two values with a single statement, which is unlike C++. Okay, so but here is a different thing. You initialize again. In C++, you initialize variables in a slightly different way. In Python, you say a comma b as if a tuple on the left hand side and 1 comma 2 tuple on the right hand side, and there will be one-to-one correspondence. A will be 1 and b will be 2. This is how Python is built. Okay, so this is very nice, absolutely nice. And then you in the morning we saw that type of a will give me the type of the variable a, type of the variable b. Now, what you can do is C equals to A plus B, and you can also look at the type of A and C, and that will also be an integer. Up to this, all fine. We have seen in the morning. Now, there is a new thing here. You will, because int A, sorry, integer A has a class name called integer, we can assume that it must have some properties also, some behavior as well. Let us see whether it has got some behavior. So how do you do that? Let us go to any anywhere. So let us say a equals to 5, and we know print type of a, and it's an integer. Now there is in Python, there is another very important tool. There are many actually, which is that if you have an object, if you can assume that a is an object, I can directly know which are the properties and the behavior of the object a. So I simply I have another function, inbuilt function called dir, and I execute dir now and I pass a as the argument, and you see that there are many such properties of a. If a were a native variable, native integer, they would not have such properties. Okay, so it tells me that it is a compound object. It's not a native object, it's a compound object. And by looking at it, you will also see that there is one such symbol is underscore underscore add underscore underscore. Okay, now if you read it, you know that this is for the operator. This is an operator which will overload the plus symbol. That means, which will overload the plus symbol means, if I do c equals to a plus b, what actually I am doing under the hood is that I have an object a, I am calling this operator, I am calling this function or method, and I am passing b as the argument. That means the plus sign is actually equivalent to this. Okay, I can see that. I can again do the same. I have a and b. I have a dot underscore underscore add underscore underscore b, and I assign that into d, and I print C and D, and I see that they are exactly the same. So this is just to demonstrate that yes, even the simplest data type, which is an integer, okay, or you can say Boolean should also behave the same way. Simplest integer also has the property of an object. Okay, so if an integer is an object, all the other more complex stuff in Python are also objects. So that way we say that Python is object oriented from ground up. Okay, so this is one thing I wanted to show you. Okay, so then I will go quickly to list. Okay, so list, I have already shown how to create a list. Then I have also shown the map function, and then we have a filter function. So let's go to an example and see whether we can look at the filter function. So there are a lot of things. Lambda we have covered more or less. Okay, this we have covered. This also we have covered. Okay, so this is one example which I'll try to type. So let us what is that? Okay, so let us put again my array, my list as list of range of 100. So if I print R, it will give me 0 something. Okay, so what I want to do is I want to collect them in another array, another list, but this time I'm not going to do a one-to-one correspondence. I will only put them if they are either even or odd. Let us put it this way. So I can have AR1 equals to again a list, unfortunately. Then instead of map, I will put filter. Okay, and then my second argument will be the original list, and the first argument will be a lambda, then x, and x will be whatever. So if the mod is divisible by 2, then you keep it, otherwise you don't. So I can execute that, and I can execute the AR1, the length of AR1. We know the length of AR is 100. Now let us see the length of AR1 is 50. And if you simply want to do AR, and you see that you have only put the even numbers and not the odd numbers. Okay. So this is filter. Again, I'm not taking help from very complicated stuff. So instead of doing this, I can also do this. AR2 equals to no list, no filter, but I put this, and I say for X in AR, and here I have to put X if okay, so now it becomes a little bit for now I always get confused about which way to put the this way or the other way. So this is what I get confused. So this is correct, and you can see that you have to know something. So you see from the lambda expression, this one is cleaner, certainly, but you have to also understand what to put where. So the last one, the leftmost one is the final output, which will be appended to the new array, new list. Then you have the loop, you have the input one for this one, and then in the rightmost part, once you have the X available on the rightmost part, you put the logic. Okay, so this is divided into 3 parts, and this is the logic. So you have the if statement sitting here. So once again, you could also do the same thing with the very standard for loop, that you create a new empty array, then you loop over the original numbers, and you do if I X divisible by 2, then you append and so on, the same as the one which we do with the map. So finally, we have the map. We have already seen some of the examples of the list comprehension. We have looked at the lambda, we have looked at the filter. So the last one is called the reduce. Reduce is, so both map and filter, they create a new list. Map will create a new list of the same size as the original one. The filter will create a new list which may not be of the same size of the original one, but should be smaller than that. I mean, either equal or smaller than that. And then there is a function called reduce, which will actually create a scalar. Okay, which will create a scalar. So let us see one example. I think these are all there, and you can see the, okay, so this one, like but in order to, we'll take our own example. In order to be reducing a list into a value, then now the reduce cannot take only one value. Okay, reduce has to take values in pair, otherwise it will not be able to do that. So for example, if I want to do a sum, of the array which I have created, I will use reduce, and I will sum them in pair. Okay, like here. Okay, so this one. So this is the example which I will take. This will the example I will take. Where is that? So so now I am this. Oh. Okay, anyhow, I have, so I will just put S, which is a scalar value. S will be a scalar value. So I have reduce, then I have lambda, I take X, comma Y. Now I have 2 arguments, and I will return X plus Y, and I will take the original, whatever, AR1. AR1. Reduce. Oh, reduce is not defined because reduce actually needs some tool, unfortunately. Wait, reduce needs some tool. What is that tool? Python reduce. It's called function tool, func tools. So if I have func tools, then still from func tools import reduce. Okay, and if I put s, then I add them up to something. Okay. All these numbers. So these are, I think, I have not taken a lot of time to explain it, but I think with very simple example, I have managed to sort of convey that there is something called functional programming in Python, where you have 5 elements. The main element is map, filter, and reduce. Okay, and alongside you have the lambda. So all these 4 put together, it's called the elements of functional programming. But nowadays, this functional programming has become less important because you have the list comprehension, and not only list comprehension, you also have comprehension on the dictionary, comprehension on other sequences also. So that way, Python has grown from, and you have already seen that sometimes the functional programming with map, lambda, filter, and reduce look absolutely ugly. Okay, because the way you use it. So if you want to do a lot of operation at the same time, then you have inside you have lambda, then you have the map, then you could have filter, you could have reduce, etc., etc. So in that case, if you want to combine a lot of stuff, like the example which is sitting here, I want to just show one such example. I think I have one example. No, here I don't have. So I have one example where you are combining like map. So we are doing something, then you are saying that I want to filter out of that. So you apply on the map output, directly on the map output, a filter. And then finally you say that I want to sum the output. So you apply the reduce. So you have reduce on the leftmost, then you have the filter, then you have the map, then you have the all the algorithms and all the, output of one becomes the input of the other. So it really looks very, very ugly. Okay, with list comprehension, if you could do that, that will also will look quite daunting. But anyhow, you can actually split them into more than one steps and keep the clarity. Okay, so the and because of some performance gain, now the recommended way is to use the list comprehension. Okay, so I think I have covered part of the functional programming, which was not very. I will now go through the functions, some important features of the functions, and I'll stop then. So, function in Python again is a first-class citizen. That means a Python function can be supplied. Python function can be supplied to a function another function, okay, as an argument, or a Python function can be returned as an object from another function. So it's like normal objects. That's why it's called the first class citizen. Okay, so it's this is written here. It can be assigned to variables, stored in data structure, passed as argument to another function, and return value as a function. Okay, you can do the series, etc. What is important is then function, like in C++, Python function also has the default value. That means if you have a function, I will not execute all of them. If you want, you can execute. If you have a function called power, okay, which takes one argument x, another argument y, you can also set a default value for y, which will always so whatever value of x you pass, it will square it. Okay, but if you want to have other way, you just supply. So if you this way, most of the time, if you think that I will do a square, you don't have to supply the second argument. You just supply the first argument and it will take the second argument from the default value. But if you supply the second argument also, that will override the default value. This is not very interesting. The other interesting one will be that all positional arguments to Python function can also be passed by keyword. This is important. That means if I have a function called display, and I really write here, I can write anything I like, creator, year, and lang. These are the three variables. Okay, and within that, you, of course, because these are the three variables, you print creator, you print year, you print lang. This is normal. This is true with every other language also. But what is interesting is that now when you call display, you can use the year here, creator, and lang. And this is interesting because in C++, you would have simply pass creator. So that will be the first argument. Then the second argument will be year, and the third argument will be language. Here you see that there is no such thing. I am using the keyword which was used to declare the function, and I am using that keyword while calling the function, which is very novel. And I also don't have to remember the order of the calling sequence. That means I can put anything as the first argument, anything as the second argument, and so on. So this gives you some power, some flexibility. Now you will ask me whether performance-wise it's bad. Maybe because Python has to actually reorder the thing so that it can correctly call it. Okay, so that will take some time. But sometimes the flexibility is more important than this. Okay, so then the two more things which are very important, which are any arbitrary number of arguments, which is there in C and C++. So, Python just inherits it. So if you want to sum up, n number of variables, okay. So what you do is you don't know what will be that n number of variables. Then you cannot really declare a Python function which will take 5 arguments or 5,000 arguments. You cannot do that. So instead of doing that, you simply do this one. Okay, you just say that I want to send a tuple. Okay, I want to send a tuple, and because my tuple could be of any size, so it is dynamic. So I will just send it, and you take care of the rest. But the way you declare it is the following: you have the argument which you will pass, and you put a star in front of the argument, which tells Python to make sure that it's a tuple of any arbitrary length. Okay, and then because it's a tuple, you can actually iterate over it and do whatever you want to do. So you can pass 3 arguments, you can pass 5 arguments, and so on. So this you have to remember. This is function arguments with arbitrary number of arguments. And similarly, you can also have a dictionary where you can pass any number of key value pairs to your function. Okay, you don't have to define. Like in the earlier case, we defined 3 variables and passed the keyword, but you don't even need that. Okay, so in that case, you have your variables. This is your name, whatever name you want to give, you will give, but you have to pass somehow magically 2 stars in front of it to signify to the Python interpreter that I am talking about a dictionary of arbitrary length. Okay, so I think that's okay. This is fine. So this is fun. I mean, I think I have covered everything about the functions which are needed to which we need to cover, and a very basic thing of the functional programming in Python. So let me, because I missed something in the morning, I'll just cover them very quickly, and I will also show you no, before I do that, I'll just show what a dictionary is. I think that is already missed. A dictionary is an unordered set of key value pairs. This I said, and the keys must be unique within a dictionary, because Python, at least this one, maybe there are alternative implementation also, which are outside the main library, which is not multi-key. So this is a single key. So if you have a key value pair, and you again insert another such the same key which is already exists with a different value, the earlier value will be removed and a new value will be inserted. Okay. So for example, if I have a list, if I have a dictionary, not list, sorry, called playmakers, and where we have all the big soccer players, like I take the first name and I take the family name. Okay. And both of them are strings. I separate them by colon. That means this is a pair, key and value pair. And then this is another key value pair, and so on. And I separate them with comma, and I put them in parentheses. So this is a dictionary. Okay. Then if you print it, okay, if you print it, then it again it will print the same thing. But you remember, you no, why it is coming? This one should not come because I did not put it. This will be sorry. Okay. So so you see that I have created the dictionary in a certain way, but when I print it, it may or may not, it may or may not follow. So let me, I think I have to show it then. So if I have a dictionary sitting here and I just print it, you see that the order is not kept. Okay, or the order is here, the order is kept. It looks like, because I have done it in a particular way. Zidane, Andre Pirlo, Iniesta, and Figo. No, here it is actually kept. Okay. Anyhow, so let me come back to that. So there are many ways. There are many ways that you can create a dictionary. Like there are many ways you can create a list, which we have seen. Okay. So what the other way will be to first create an empty dictionary, and then you just by yourself fill the key value pairs. You say that I have a dictionary, and if I give the key as this one, the value will be this. It's like a list, but instead of 0, 1, 2, 3, like the indices, now the indices are the keys. Okay, but otherwise it looks the same. So this is not the recommended way, of course. You can, the more important thing, and if I give you two lists and I ask you to create a dictionary out of the two lists, so first thing you will check whether the two lists are of the same size, and you will also ask yourself or whoever gives you the list whether there is a one-to-one correspondence between the index of first list and the second list. That means 0th element of the first list corresponds to the 0th element of the second list, and so on. If those are the same, then the idiomatic way of doing it is very, very simple, and probably much faster than if you do it by hand. You can do it by hand, as we already discussed, with a for loop, but the idiomatic way is to call something called a zip. So if you have a function called zip, and you just give the given the first list and the second list, it will automatically create a dictionary. And of course, Python 3 will require that you also create explicitly the dictionary. So you put a, like we put list, you put a dict here, and it will create a dictionary for you. Okay, so this is, if you have two lists, this is the idiomatic way, and not this one, but you can do it always. This you already know now. Okay, so if you have explicit, you have the constructor of the dict object, you can also create a dictionary in a slightly different way. I am explaining all of them because you will see all of them here and there. So one, instead of the colon, you will see that you have the key, and you have a value equals to this value. Similarly for the others. So this is also a valid way of creating a dictionary. Okay, this is also a valid way of creating a dictionary, because you have a constructor for the dict object or dict object which takes this grammar. Okay, so you can create it. Once you have created it, they all look the same and they will print the same way as we have seen. Now, for example, if you have a single list instead of double list, so you have Zinedine Zidane, Andre Pirlo, blah blah blah, then you know that the 0 and 2, then 4 and the this one, the last one, okay, and not last one, 1 2 3 4 5 6 7, so sixth. So these are the key, the others are the value. So how do I create a dictionary out of that? Okay, again, if you want, you can go through a for loop. You can create an empty dictionary, go through a for loop over the list, and you can collect the alternative element. 0 is the key, second is the value, and so on. You can do that, or you can, it might not be very difficult. You can also do with a list comprehension. Okay, you can check yourself whether it works, and you will see that after you created a new list, okay, which looks like this, if you convert into a dictionary, it will be converted into a dictionary. Okay, so once you have given a dictionary, you can remove elements, you can add more elements, you can count the number of keys, you can only extract the keys, you can only extract the values, and so on. All of them are there afterwards. Okay, I'm not, you can like if you want to have only the keys, you have a function called keys. If you only want to look at the values, you can call the values. If you want to get pairwise all the items, you have to call items. So if you say playmakers dot items, it will give you pairwise all the items, and so on. And as I said, you can delete some key. If you delete a key, the corresponding value will also disappear, and for that you have to use the del operator. Okay, so I think these are the, and of course in a dictionary, what is also very important when you do your any operation is to check whether a key exists in a dictionary before you actually take an action. So what you can do, you can say if playmaker is your dictionary, you can say Louis in playmaker. Okay, this will tell you whether this key called Louis is inside the playmaker dictionary. So because we have already removed it, it is false now. Okay, similarly, if you say that I have a playmaker dictionary, I get the key, then it will return you the value. There's a get function which will method which will return you the value, and you can do pop, etc., just to remove elements and so on. So dictionary are very much used in Python. So we need to keep an, so set is another container. Just I'll take 2-3 more minutes, where you have only unique elements. Okay, so for example, if you have a list, called apple, orange, apple, pear, orange, banana, that means you have orange and apple appearing twice. For a list it is fine. Okay, but for a set it is not fine. So as soon as you have a set constructor and you pass set can be created from a list, as soon as you do this, that you say set over basket, and you return into another sequence, which is a set sequence, and you print the set, and you see that you have only unique elements. Okay, so I will give you an exercise about the set, although so now you can check whether orange is there in fruits. So orange in fruits, true. Mango in fruits, false, because we don't have any mango. So there is one example here. Okay, you see that I have two sets, abracadabra and whatever. And if you and there is a lot of repetition of A, probably B also, R also, etc. But if you simply look at A, and this set is created from a list of characters, and you see that you have only unique elements. Similarly, if B also is created from elements, if you have A, L, C, Z, and M. Okay, now you have already implemented the operator overloading, so you can do some mathematical operation. You can say A minus B, you can say A or B, you can say A and B, and you can also say A no XOR B. Okay, all of them will be available to you. So this is in sets are used in some way when you have very large data set with a lot of repetition, and you want to this exercise. I think I'll give you tomorrow, and it will be if you can do it, is good. That if I give you two huge files, okay, and I ask you find the numbers which appear only in file 1 and not in file 2, or the other way around, or the common numbers. Okay, I can also ask you that given a file with a lot of numbers, you find how many times a single number is repeated. Okay, so this is whether it's a set problem or some other problem, you have to find out. Okay, something like this. Okay, so I'll stop